Hello, everybody. So I'm here today to tell you about AI agents. So in particular, I'm going to be talking about something called Orchestral AI, which is a project of mine. I actually started developing this along with my brother Jake back in early last year, and it's sort of grown into this framework for AI agent orchestration. But I'm going to have to define some of these terms, I think. So in this talk, first of all, we're going to define what we're talking about with, I'm sure everyone has heard of LLMs, but specifically what are they, what do we mean by context, what are agents, and then go on to things like tools, which I'm going to be talking about a lot in a moment. Some of the difficulties of actually building these things in practice, and how our system that we're sort of here selling off helps. And I'm going to try to hopefully give you a live demo, although if the previous difficulties are any indication, maybe we just shouldn't. Finally, close with some thoughts about abstraction, a bit of philosophy, and some applications to science. So first of all, we've all heard all the time about LLMs, large language models. What these things are in practice is they're transformers, which is a kind of machine learning architecture that are pre-trained on a massive corpus of text, right? And they're used to autoregressively generate text, given some context. I'm going to be talking about this term, context. Context is just the input into these agents, into these language models. That's everything that has happened in the conversation so far. So, so you're given some sort of string like this. It was the best of times, it was the, and now as humans, you do something very similar. You might have an inkling of what should follow, and, transformers and LLMs have a probability distribution of what should follow. So apparently, worst wins. That is, like in this one example, 70% likely, and we sample from that, and that's how we generate text. So it's just a machine that takes context and outputs things, and this is called, and the fact that we do this again and again is autoregressive generation. Okay, so I have talked about agents. What is an agent? So in general, in sort of the broader context of math and reinforcement learning, an agent, sort of laying out the framework of a Markov decision process, is a system which, first of all, observes some state that it's in. You can imagine you're playing chess, say, you observe the board state, and then you choose an action that you can do out of your possible set of actions. In chess, that would be legal moves. In language models, that might be something like producing a token out of a distribution. That's sort of like a policy. Sampling from a policy. And then that action has an effect on the state, and in turn changes the state. So AI chatbots are sort of trivially agents in the sense that they're taking actions which is generating words, but they're not really goal-directed, and the actions that they take don't affect any external state besides the conversation that you're having with them. So generally, in common usage, we don't consider chatbots to be agents. They don't have any sort of agentic behavior. They don't want anything. They don't seek goals or pursue goals. So an AI agent is a system which does this, but it has sort of a broader effect on some system. So what we're going to do is we're going to sort of enhance it by equipping it with tools. So now I'll define for you what is a tool. So a little bit of history. Back in 2023, shortly after the release of ChatGPT in 2022, companies like OpenAI began fine-tuning their LLMs. Not the same kind of fine-tuning as our earlier session, but they are sort of trying to get them to reliably give outputs as a JSON, which is just a simple structure file type. This was meant to improve the reliability, get them to sort of behave in predictable ways so you could actually connect them to things. So once this sort of got working reliably, we were able to do what's called function calling, where the LLM will actually select the function. So out of a set of given functions that it knows about, it will do in-context reasoning to decide, oh, in this situation, I'm going to now choose to use a function, so let me say what function I'm going to use, and now let me also say the arguments that I'd like to pass into that function. So it's a bit of a small distinction, but once you start, maybe more of a perspective shift actually, these functions we now call tools when they're connected to some external structure, some sort of external API or software or database or something that can actually affect the world outside of its conversation. So we built tools to extend the model's capability beyond its training. So a classic example is a tool to get the weather. You know that language models have all sorts of information, but that's all baked into their models, you know? They don't, for instance, know the current weather in Paris. That information is simply not available to them. But they might know that they're equipped with a get weather tool, which accepts as an input a string of a location, okay? So you tell it this, and then when you say to the user, or when the user says, so the user's message comes in, says, hey, what's the weather in Paris? The language model decides, oh, I have this, the user's asking me about the weather in Paris. I obviously don't know that information. I have this get weather tool. I'll call that tool. That call goes to the developer, or to the sort of thing that's calling them, which is what Orchestral is. We handle identifying and executing that thing and return the result to the model. Now it has sort of been informed in context about the thing that it didn't know about, for instance. So now it got temperature is 14, and so finally we can return to the user with the right answer. So you may, if you've used ChatGPT or any AIs recently, they all do this in some form. So you can like ask it questions now and it will search Google and find out. So that's a very powerful idea. Another powerful idea I just want to touch on briefly is the idea of orchestration. This is the idea of taking multiple agents and getting them to work together to some shared objective. So you can have a whole team of agents, say, and if you can figure out how to do it, it's kind of a non-trivial problem, you can imagine, sort of by analogy with humans working together, how these AIs might be able to work together and extend their capabilities beyond what any one of them could individually do. So that's called orchestration. And now let me just say that all of this stuff, while I don't know how simple it sounds in theory, but how simple it is in theory, is actually kind of a pain in practice if you just want to sit down at your computer and code this stuff. So for one thing, you have to handle the sort of logic of these conversations, creating the JSON schemas associated with the tools, which tells it exactly, the name of the tool, the arguments, possible values that it could have. That's all kind of a pain. In the past, Jake and I were actually writing things like this explicitly, and it's still fun. And likewise, there's a zoo of different AIs out there and different models, and it's, a whole bunch of technical work to get these things, interoperable. Likewise, they cost money, you have to track that, you have to sort of manage what's in the context, sort of an idea that good context engineering means that you're preserving only the salient detail, only the words that actually contain some signal that's actually useful to the task at hand. So there's a lot of stuff going on. So we introduce Orchestral AI. You can see my logo there, which I'm very proud of. This is a Python framework, as I said, for deploying these things, and it abstracts away all the unnecessary details. I will show you in a moment that it has a beautiful UI that I've created, and I'm also very proud of. And you can also actually use this, and I'll tell you how at the end of the talk. There's also a whole suite of tools we've given access to. If you've used something like Claude Code, this is very much comparable to Claude Code in its feature set. And likewise, we've actually had situations where one of the tools we give it is the ability to execute terminal commands on your computer. Now, you can imagine that there are, conceivable strings of things that you ought not write into your terminal. And we've actually had a situation, Tony in the back, who will talk next, has had a situation like this where it tried to execute something it shouldn't have. And so we actually have smart features for sort of preventing those kinds of bad behaviors. Okay, so now, very fraught part of the talk, I want to give you a live demo. Now, I don't know if you know this, this is how bad live demos could go. So let's see how we do. I'm going to take this over here. Yeah, no, wait, I know what to do. So, okay, this is Orchestral AI, the interface that we made. So you can see that it resembles other things like ChatGPT. So you can actually launch this very easily from your terminal, and it's all written in Python, and you have access to control and customize a lot of what actually happens in the Python. So you have different conversations you've had there. We can say hi to it, and it will, or it ought to stream back its response, very ChatGPT-like. But you know, there's some other features that are a little bit beyond ChatGPT, and there's some other features which are completely impossible with ChatGPT. One thing that I'll note, which is sort of a nice little quality of life thing here, is you can see how much this conversation has cost you. You can see how much, this is funny because I'm actually spending kind of a lot of money on my API bills, so I gotta make some extra money to cover those. You can set a limit for the maximum cost you're willing to pay, also important. You can select between a wide family of different models. There's other things like this. One thing that I don't really think to highlight, but we also are writing papers about these things. So we have export to LaTeX. We have a beautiful way of actually putting this thing in LaTeX. You just copy your messages into LaTeX. And when you check out our aforementioned papers, maybe you'll see some examples of that. Also, you have a lot of fine-grained control over what's actually happening here. Crucially, the whole thing points at a workspace. So we can ask the agent to do something like this. So we can say, please ls. And this is an example of it actually running a command. Please work. Okay, thank you. So let me just do something else here that I probably shouldn't do. Okay, so so you can see here, look over here, that, where does it say app? Okay, this is the actual workspace, so it lives here. It has access to your computer and can sort of run stuff here, so it just ls and saw all of these things. Sure enough, that's the case. We can ask it also to just sort of highlight a couple more things, and then I'll get back to the broader science of it. Please test all of your tools. So, and this, and it decided to make a plot, which it displays for us. It can also, read and write files, diff files, find files. These are very useful for it because it basically is a programmer. And it also has a to-do list that it can run. So I want to highlight something else though, which is so again, this is all basically comparable to Claude code. So one thing that we can do that I think is very cool from a point of view of someone building agents to do science is I can actually make my own tools. And I want to show you how easy that is. So I've pre-made something called search archive. I've just made a little function here, which is just some classic function that calls the archive API, because apparently archive has an API. So everyone needs to search the archive for things, and our agent should be able to as well. So let me go here, and so what you do is you write a function like this. You provide the arguments as you normally would for a function, but these are going to be read by the AI, and it's going to understand that this is how it needs to output and automatically generate that nasty tool schema thing I showed you about earlier. Likewise, it's good practice in programming to write a docstring. So the docstring is automatically read by the agent as the prompt, explaining to it how and when to use this tool. So that's an elegant thing. So basically, just by writing clean code, you can do this. You can define a tool just like this. So you say from orchestral import define tool, and then you go here and define tool with the decorator, and then we just go here and basically connect it to the function we imported. That will do for me. And now here's the really hard part. That was called run at Miami. So here's the one I just defined. So I should have just given it the ability to search the archive. Let's see if it works. Do you think it's going to work? Please search the archive for fine-tuning something. So it knows that it has this thing. Okay, and it just got the first 5 papers that come up. It actually worked. Nice. So it just decided to call the archive search function with the query fine-tuning. And of course, it could be extended a lot past there, but basically, the only thing I did in advance was write the function in the prompt. But those are, easy tasks. Those are just classical programming tasks, and now also prompt engineering. But we were able to add a archive search function. So I'm going to close out my live demo here, and then I'll also note that I've recently added a feature for something I call a sub-agent, which is, can you do something about that? Okay, where's our presentation? Okay, so what do you think? Did we do better than that guy did? Maybe a little bit. Okay, so how am I doing on time? Counting the 5-minute delay, be a few more than that. Okay. So there's this quote from Alfred North Whitehead that civilization advances by extending the number of important operations which we can perform without thinking about them. So I think that this drives a lot of the development. A lot of orchestral has been motivated by this philosophy. It's true in a trivial sense that we are now making operations easier. We don't have to think about all those nasty things that I left out in the beginning that I said are a pain to deal with, and this abstracts those away. But it's true also in a more important sense. We can make it easy to define agentic subroutines to do tasks and do complicated operations without us having to think about them. So I think this is an immensely powerful idea. So we can, for example, define flexible sub-agents which can be called recursively to automate increasingly complicated workflows. Basically, anything that you can do, any subtasks that you can do as part of your job, say, you could theoretically codify and build tools for an agent to do that, and then make a sub-agent that does that, and then have ever-increasing recursive, structures of agents calling sub-agents, calling sub-sub-agents that are doing basically an unlimited suite of tasks. Anything that you can build a tool for, and that the agent can reliably do. Now, agents can't reliably do everything that we do, thankfully, but the base models are improving. The LLMs are getting smarter, and the coherence horizon of these models is increasing. Also, we treat sub-agents as tools, and so we can take complicated things and turn them into a simple high-level operation that the agent can do without thinking about it. The agent just says, make it happen. Works more like a manager, I don't want to know the details, get it done. What did Whitehead have in mind in this quote? Well, it's actually from this Introduction to Mathematics. He gives a couple of examples. For instance, algebraic and symbolic notation allow us to not think about some lower level things. You get good at calculus. You don't have to think about the definition of a derivative. How language and grammar allow us to effortlessly convey complex tasks with really compress information and convey complex ideas effortlessly. I like this one. How money and accounting, how prices encode complex information about supply and demand. That's something you don't have to think about. You don't have to think about the price of wheat when you go buy a burger. It's just handled effortlessly. And of course, scientific laws. We don't have to, be Newton and reinvent the wheel, so to speak. Maybe that would be the best example. Every time we want to use the wheel. So I would say that in the future, we can build abstractions explicitly with agents. Things like designing and executing a simulation to test a hypothesis. Writing complex code bases. These are two things that I actually use agents for now, that are actually getting more and more autonomous, that we're building better and better systems to do effortlessly. And this, in turn, is improving the productivity of scientific researchers, software engineers, and anyone who's using these things effectively. Sorry. Yeah, write complex, organizing conferences. Could be an opportunity there. Okay. I'll finish up by talking about applications to science. So, as I said, we're working on several projects, as Konstantin said. We have a paper which will be going on the archive any day now. Has it already gone on the archive? Thank you. Which is using agents to automatically test designs for variational quantum circuits. Another one we call Aster. This is also going on the archive, probably in the next week or so. Agentic science toolkit for exoplanet research. We're building a toolkit which can run Bayesian retrievals, forward models of exoplanets, spectra, and test hypotheses about their composition. And also it can search the astronomy equivalent of the archive ADS and look at papers there. And so we're building up tools to try to make these things happen. Next talk you'll hear about Heptapod from Tony. I won't mention that more, but it's high energy physics toolkit for agents. Some other things as well, and as Konstantin said, this is also working in collaboration with Fermilab. Okay, so that pretty much concludes my talk. I'll just sort of conclude by saying that we have a white paper that we're putting out. You can actually pip install Orchestral AI. You do need some API keys from LLM providers because these things cost a little bit of money. But other than that, you can basically do what I just did here. As I said, we have these papers, and let me also just shout out one more time. So this is our white paper, and the co-authors are myself and my brother Jake, who is instrumental in creating Orchestral. So I'll finish there. Thank you.
Thank you. Can you mention a little bit about the permissions that this thing will have? Because you mentioned how it already ran some kind of malicious command in the terminal. I'm just curious, what security are you putting in place?
Yeah, so the basic idea is you can sort of sandbox its execution. So we're not doing a tremendous amount of sandboxing right now, but you could say execute these things in Docker containers, and then they can only do so much damage, hopefully. The other thing is that you can sort of inspect every action that they take, and you can use classical filtering to look for things that are worrying, like just flag commands like exec and remove and different things. And then one more thing, and then you can also use LLM as a judge for that. And then we've also implemented user approval. So anytime something happens, you can approve it or deny it, and that helps, I think, build trust that it's not going to kill you. What was that?
Okay, so when you say you can inspect the command, it basically tells you, hey, I'm going to run these.
Yep.
Are these okay? And
yep,
then you approve
exactly. It tries to run it, and then the sort of subroutine detects that, and without the agent ever really knowing about it, it sort of pauses, says, is this okay? And then goes back to continue execution if you permit it, or if you interrupt it, you can tell it to do something else. That's basically the idea. But it is a sort of non-trivial problem, because as these things get smarter and more capable, our ways of sandboxing and putting guardrails on them have to also become smarter and more capable. It's actually a security problem. And there have been some really interesting examples of agents doing actually harmful activities, both in practice and in simulated environments. Any other questions? Yes, sir.
I have a question. It's probably too general task here, but I just want to start thinking about this. I mean, when you're running simulations, right, we already have a problem that we don't fully understand what's coming out of a simulation, so we don't trust it. Now you tell me I'm going to ask this thing to run a simulation, and the amount of details I have to understand, what approximations were made, what scales were you using? When you ran into multi-scales, how did you connect those two scales?
Yeah.
What are the possible questions that your results are giving me that I can ask versus what are the possible questions I should not ask of those results because certain things were emphasized? The simulation is just vastly complicated. And so now I feel like what I'm seeing with AI, or the concern my question would have to do with, by the time I find out everything it's doing, I feel like I could have done all this.
Yeah, that's very
In other
interesting.
words, like, I mean, I can't just tell it to do it because I can't trust it, and I will
Yeah.
never be able to trust it.
Well,
Right? In
this-
some sense, we can't trust people to do it, so we always check their work.
It's a little bit like saying we can't have cars drive themselves because they can never be completely perfect. But maybe they only have
I
to
think
be-
it's vastly different because the car situation is extremely well defined.
Well, I mean,
From
we're
a-
talking
from a-
about a theoretical experiment. Now that's kind of ambiguous. You know, it could be a very complicated or very simple experiment. And I'm only
Yeah.
making a general statement. Of course, in practice with complicated experiments where there's a lot of details that you need to double check, there you might benefit less from this kind of thing. I totally agree. A general big problem, I would classify this as a whole field, human-computer interaction, which is trying, agents or LLMs in general. I know a lot of people that complain about ChatGPT being so stupid. It suggested this thing that makes no sense. I think a lot of these failure modes just fall into the category of they don't have adequate context. You need to give it adequate context about what you actually want.
That's a
It's
good point. So the
underspecified.
prompting.
Yes. So
Suppose I need to
prompting-
write a 500-word essay.
Yeah, right.
But my prompt has to be locally,
Yeah.
roughly 500 words.
So this again is in the field of human-computer interaction because these kinds of things can be solved by you working harder, or you can have a smarter system that gets to know you, that has better priors, better default behavior, but also has a history of interaction, so it remembers the other mistakes that it made, and sort of learns from those. Those things can all help to inform its context. Now, the interpretability and the transparency about what it's actually doing is also a real problem. That's why one of the sort of guiding principles with our interface is to make it completely explicit what the agent has actually done. So you can just read through exactly what it's done. And we have ideas in terms of having secondary agents that say evaluate it versus some spec, different things that you could try to do to audit what's actually going on when it becomes too complicated for a human to do it. But also maybe you just have to empirically validate that it does work, because you say I can never trust it. I don't know, maybe if it's as good as your grad student, you can start to trust it.
Yeah.
Well, this is part one of our 2 talks, and so the next one will actually implement
Some of them.
Tony can answer some of these.
and then we can revisit your question, because then we'll have a real example in the field of particle.
Thank you for these questions, they're very insightful.
All right, let's thank Alex, and